Karnaugh maps of 5 and 6 variables. It's possible to optimize Boolean equations that have more than 4 variables using K-maps. However, we have to think a little bit more about the topology of the K-map that makes it work. If we think about the original K-map of 4 variables, say we have input variables A, B, C, D, then we draw our K-map. It's going to have a total of 16 entries because there are 16 entries in the truth table of a 4-variable function. So we can say our function Q equals some function of A, B, C, and D. And we're going to just list the gray code count here for completeness. 0, 0, 0, 1, 1, 1, 1, 0, right? How do we do the optimization? The key for making the Karnaugh map work is to recognize that there's only 1 bit transition from one column to the next or one row to the next. Also, when wrapping around, only 1 bit transitions. So when we group, we are saying that there is a don't care over a variable within that group. One or more variables potentially, if you have multiple rows or multiple columns. So how do we extend this 4-variable to 5-variable? One technique is to think of this in 3 dimensions. Let's say we have 3 dimensions like this, and we have a 4-variable K-map here. Let's also think about, well, what if we wanted to extend it to 5? We could just place a second plane right above it. So instead of separating out and showing all 16 entries, let's just draw 2 planes like so. Now what's interesting is that we can draw a grouping across like this between the 2 planes, which is kind of nice. However, drawing the K-maps in 3 dimensions like this is a little bit cumbersome. So a good way to do this is to say we are going to draw it as 2 layers side by side. So say we have Q equals some function of A, B, C, D, and E. Let's say A is our most significant bit, so we will place B, C, D, and E here. Oops. And we can fill in our entries. So we have a total of 16 on one side. Let's call this the A prime side. And we can create the A side here, where A is not inverted. B, C, D, E. This is the A side here. Let's say we had a function 2, 3, 4, 5, 6, 7, 8. No, actually this is going to, yeah, let's do this. And we can place some entries here. And the entries that have not been listed with ones, we're just going to assume that they are valued at 0. So this is an arbitrary function for illustrative purposes. How do we group it? Well, we have, let's see here. We have a group here. Let's add those two ones over there. And we can say that we have this row, B prime and C prime, D and E are don't cares. But it's on the A prime side. So we say for that first term, A prime, because it's only on one side, B prime ended with C prime. Now, we could come over to this other side, the A side, and box this one. Let's draw the gray code so that it's complete, and it's a little bit easier to see what we're referring to. The next term, which I grouped here, is equal to A, because it's on the A side, right? And it's ANDed with B prime and D prime. So it's exactly the same as the 4-input case. We just need to remember to include the term that represents the side that it's on. Our next term is a bit tricky. We have this one here and this one here. It is possible to say these are two separate groups, but notice that these can be shared across. These can be shared across both sides. So rather than say that it's unique to A prime or A, we're just going to leave the A variable off, and we're going to say the value is B, C prime, D. And this completes the Boolean expression optimization from the K-map. It's kind of nice to have 3 dimensions and where we can extend it to 4 variables or 5 variables. If we wanted to, and it was hard to view in 3 dimensions, another way of writing it is to say we have, for this term, A prime, B, C prime, D, and we have for this term A, B, or A, B, C prime, and D. If we take A prime, B, C prime, and D, and then we OR that with A, B, C prime, and D, we can factor out the B, C prime, D term, and we have A prime or A, and this simplifies to 1. So we are left with B, C prime, D, which is the same as this term here. We see that this approach works. What about 6 variables? Six variables is a little bit tricky. But now that we know the pattern of placing 2 K-maps side by side, it's very easy to extend it to the 6 variable. So we can declare a function of 6 variables, q equals q of A, B, C, D, E, and F. This is a possibility. Well, let's say A and B are our most significant bits. C, D, E, F. And we can do this. 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. We can also uh, uh, list a second one here. C, D, E, F. This extends to 5 variables. We can say this is the B prime side and the B side. How do we extend it to 6 variables with A? Notice that we have 16 bits per 4 variable K-map. So 16 here, 16 entries here. We need a total of 32 entries on our truth table for a 5 variable function. But what about for 6 variable? For 6 variable, we need 2 to the power of 6 equals 64 entries. So we need to add a second row of K-maps. C, D, E, F. And this would be C, D, E, and F over here for our second set. So we need another 32 entries on the bottom. The reason for this is we wish to say that this is up here the A prime side. So A prime, B prime, A prime, B. Then we have A, B prime, and A, B. Now it's possible to draw a group that is across all 4 of these. And by connecting these 4 bits together into a group, we can simplify without too much trouble. Though when we're drawing arrows, it gets a bit ugly. It gets quite a bit ugly. So one way to solve this problem is to move to Excel and use colored boxes and fonts of different colors and styles to simplify our lives. Let's try this now. So we can say C, D, E, F, right? Let's highlight all our boxes. Let's format the cells. Right-click and format. So remember, for the number, we wish to set the value to, or the category to text. Text. This allows us to have preceding zeros in our bit sequences. Our alignment, we can set the horizontal to center. And for the border, we can give it an outline and an inside. This is 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. And then we can go and highlight this, copy, and paste it in 4 locations. We can then label each one as A prime, B prime, A prime, B, A, B prime, and A, B respectively. So if I wanted to place a group here, or I saw a group placed here, and let's say we have another group that is across here, right? And let's say we have another group that is shared here and here. How do we highlight these? Well, let's highlight these two, and we can set this to a common background color. And we see that this is representative of our term. That term is B prime, because the A is a don't care. We have a C, E prime, F prime. Okay? This is our style. Now let's look at these 4 here. Okay, these 4 we can set to blue color, for instance, and we will call this C, D prime, E, F. And we can set our background color. Let's say we highlight these 4 now, and we can set a foreground color of red just to have some variation. Remember, we can share across groups, so having a foreground color and a background color allows 2 groups to share a 1. And also it's possible to use bold, italics, and underlines, so please feel free to use these as needed. This term now is A, and because it's these 2 on the bottom, we see that A is shared, B is a don't care, right? And then we have C prime, and then we have E and F. Let's give it color marking. And now we have marked each of the groups and labeled them, or labeled the terms that are developed from each group. And this is an example of how to keep track of more than 4 variables in a K-map to do optimization.